Today, we're talking about primates. All right, so we're going to get into great detail about this group of mammals, and so hold on to your hats. All right, this is going to be a good one. I wish we had some live specimens here, but we'll make do with our little casts here of their skulls. That'll be just fine. All right, so this is an order, taxonomically, the order Primates. And this order is characterized by their agility in trees, something I wish I had, their agility in trees in general, and they have a large brain and acute vision. Additionally, they have kind of more of a flattened face that allows for stereoscopic vision. So stereoscopic vision means that the eyes are positioned such that they can focus on one object and perceive depth, basically. So stereoscopic vision is specific to primates. Additionally, their parental care is unique in that it's attentive, if you will. You probably know this. So their parental care is attentive, and they actually have relatively long lives with respect to other mammals and other organisms. So primates range in weight from 30 grams, tiny, a pygmy mouse lemur, to 175 kilograms with your gorilla. That's a huge range. So the earliest probable primates was around the late Cretaceous, and radiation of true primates occurred in the Eocene, so much later actually. And that radiation kind of started with the emergence of lemur-like tree climbers. The closest non-primate relative is Scandentia, and those are your tree shrews. So tree shrews have padded fingers, and they have an unusually large brain for a mammal. So we're kind of getting towards that large brain case, that large brain that primates exhibit. So primate evolution has been mapped out with some degree of certainty. There's definitely some missing puzzle pieces, but I kind of like to walk you through from the order level taxonomically all the way up to the superfamily group that we'll be referring today. So I kind of want to give you a chart here that you can follow as we throw out some of these names of these taxonomical groups. So it starts at the bottom with primates as the order. It branches into two suborders, Strepsirini and Haplorini. We're going to follow Haplorini even more in depth, and Haplorini branches into two infraorders, the Tarsiers and Anthropoidea. The Anthropoidea infraorder branches into Platyrini, a parv order, and Catarrhini, another parv order. Following Catarrhini a little bit more closely, that parv order divides into Hominoidea and Cercopithecodea, and these are two superfamilies that we'll be discussing today. So if we can dive in here with our first group, the Strepsirini, these are your lemurs, lorises, and galagos, and they're identified by their wet noses, actually. So that's a distinguishing morphological feature or function, is the presence of a wet nose. Interesting. They have a smaller brain-to-body ratio than other primates, and they're mostly nocturnal and tree-dwelling. The group Haplorini includes your Tarsiers and your Anthropoidea. And your tarsiers are generally unlike primates, and it's kind of been a source of contention as far as where the tarsiers actually belong in this evolutionary process, so in their phylogenetic relationship with the other primates. So it's just something to keep in mind. So they're generally unlike other primates. And the other group is the Anthropoidea. Anthropoidea is then divided into several groups that we've mentioned before, and we'll start with the Platyrini. Platyrini arose in the Oligocene and persist in the recent. And they're called New World monkeys. So if you hear that term, the New World monkeys are referring to this group Platyrini, and they live in Central and South America. So our New World monkeys here, we have a skull of a New World monkey. And the New World monkeys actually have prehensile tails that can be used as a fifth limb. So that's what prehensile means. It actually can be used as another limb. So probably very advantageous when you're climbing through the trees, I'm sure. And the name Platyrini refers to, it actually means flat nose. So we're kind of referring to like their facial structure here. So Platyrini. And some of the New World monkeys actually lack an opposable thumb, something to note. And they have an extra premolar with reference to the Old World monkeys, the next group we'll talk about, and the apes. So if we can take a look a little bit closer here, we're identifying this group of primates based on the dental formula. So we have our incisors in the front, our canines are next, and then starting to get towards the back of the mouth, we have 1, 2, 3 premolars, and 1, 2, 3 molars. So that dental formula, it's 2, 1, 3, 3 on the top and 2, 1, 3, 3 on the bottom. That actually distinguishes your New World monkeys from your Old World monkeys. The next group within Anthropoidea are the Catarrhini primates. They arose in the Oligocene and persist in the recent. And within Catarrhini, we're going to zero in on the Cercopithecoidea. And these are your Old World monkeys. Oh, let's get our big example here of Old World monkeys. All right, we have a big gorilla here. And so I'll put him down to continue. All right, so we're zeroing in on these large primates, our Old World monkeys, that refers to, Old World refers to Africa and Asia actually here. And Old World monkeys lack a prehensile tail, and they have narrow, kind of downward pointing nostrils, which is different from the Platyrrhini, which kind of had, remember that was named for their flat face. Their nostrils kind of facing forward actually, or pointing forward. These have narrow, downward pointing nostrils. Their dental formula, let's see, who's it gonna be? All right, how about this one? So their dental formula distinguishes them from the New World monkeys. And so if we can go through here again really quickly, starting in the mesial part of the jaw, the midline, we have 2 incisors, 1 canine, 2 premolars actually, and that's the distinction between Old and New World monkeys, these 2 premolars and the 3 molars. Examples of Old World monkeys are your baboons and other African monkeys. So our next superfamily within the group Catarrhini are your Hominoidea. And so here's where we start marching through the trek towards human, or in a human evolution, towards our modern day Homo sapiens. So within the superfamily Hominoidea, we have 2 families, the Hylobatidae and the Hominidae. So I know we got a lot of similar terms here, so let's just try to keep those straight. I'll try to be clear and concise. So our Hylobatidae are your gibbons and siamangs, and these are kind of they're termed like your lesser apes. Your lesser apes, and they're the fastest of all animals in the trees. So this Hylobatidae group, your gibbons and siamangs, these are your fastest animals in the trees. Pretty interesting there, good group. The Hominidae, these are your orangutans, African apes, and humans. All right, so we're Hominidae here. And these are termed greater apes, great apes. So the Hominidae, this group, they evolved in East Africa, and some moved into Asia and now represented by orangutans. Kind of an interesting note here, just I want to bring this up. There's a group within your Hominidae called Gigantopithecus. And Gigantopithecus was thought to arise around 5 million years ago and maybe persisted until about 100,000 years ago, but that end date is under contention, so we'll see how that works out in the future here. But Gigantopithecus lived in Southeast China and is the largest known ape. And here's where you're gonna knock your socks off. So Gigantopithecus was 6 to 9 feet tall. Whoa. That is a huge primate. 6 to 9 feet tall and over 600 pounds. Holy smokes. That is a really huge, huge primate. And something kind of interesting, if we could add a little mythical element here, Gigantopithecus was thought to maybe inspire these stories of Yetiss or Bigfoot or Sasquatch. Who knows? So Gigantopithecus, kind of an interesting primate there. So the split between apes and humans is thought to be approximately around 7 million years ago. And if we could kind of define a human, the features that we would identify are that we have a larger brain and we're bipedal. So that's actually distinct with humans in contrast to some of the other apes or the other primates, is we're bipedal, meaning walking and running on 2 legs or 2 limbs. So it's thought that the walking came first and then the development of the larger brain actually followed that process. So the larger brain is only found in the genus Homo, which again, these dates could be altered a little bit with further research, but the genus Homo in around 2 million years ago. So something to keep in mind there, that walking is thought to have come first and then the development of that larger brain. So adaptations for walking included a non-opposable toe. You may have noticed that on your own body, a non-opposable toe, and a straight hinged knee actually. So it kind of bends forward and backwards as opposed to kind of projecting out to the side more. So a straight hinged knee. And then the foramen magnum, if I could pick up one of our specimens here. The foramen magnum is this huge window, basically, this large hole at the base of the skull that allows the passage of the spinal cord to go into the brain, basically, to connect with the brain. And so here we have our old world ape. And on a human skull, we also have that foramen magnum. And what we want to look at is the position of that opening, where it is on the skull with relation to the rest of his body. So if I can refer back to our interesting gorilla here, you'll see that the foramen magnum is kind of towards the back of the skull, here. And I'll, again, contrast to our human, where the foramen magnum is actually almost in the center of the skull, so pointing downwards. And what we're referring to here is how was the head to body kind of angle or position, how did that differ between those two groups? So you can imagine if you're standing upright, your support system, your axial support, your spinal cord is almost going to be going into the middle of your head. Whereas if you're kind of crouched over, if you're quadrupedal, that foramen magnum would be in the back of your skull projecting kind of almost at an angle back towards the ground. So this is something that distinguishes humans from other apes, is that position of the foramen magnum.